In this last video, we're going to take a look at the intermediate value theorem, which is another big named theorem, so it's one that I think is worth knowing, but I think it is fairly intuitive once you can kind of see a picture of it. So I'll draw it out and explain it as best I can. So suppose that f is some continuous function on a closed interval a to b, and L is some number strictly between f of a and f of b. Then there is some number c in the open interval ab such that f of c is equal to L. So there's kind of a lot happening here. Let's draw ourselves a picture. So let's say here's a and here's b. And let's do our function in blue here. Let's say my function looks like this. Let's say here's what our function looks like on this interval a to b. So the important part of this, and what all of this relies on, is that f is continuous on this interval a to b. And so here we know that L is some number between f of a and f of b, and that refers to just the y values of our function at a and b. So here is f of a, and then here is f of b. And we're going to pick some number. We're going to pick an L that's strictly between these two. So it can't be f of b or it can't be f of a, but it can be anything in between. So let's just say it's right here. Let's say this is L. What this means is that this theorem guarantees that there is some number between a and b such that if you take that number and plug it into your function, you get back L. So this would be my C right here. So the way I've always thought about it, this is just kind of a specific example, but I think it makes a lot of sense. Something that's continuous would be something like the temperature outside, right? So when I say continuous, what I mean in this context is it's never really going to jump from 30 degrees to 80 degrees instantly, right? It's going to happen over a long period of time. It's going to happen gradually. So it never jumps between two different temperatures, just like that. It's going to happen over time. So if you wake up in the morning, let's say it's in the wintertime, you wake up in the morning and it's negative 10 degrees outside, and you drive your car to Moraine Valley or wherever it is that you're going, and by the time you get there, it's now 20 degrees outside. So it started off at negative 10 degrees. It's now 20 degrees. Well, that means that some point in between those two, it had to have been 0 degrees, right? It had to have crossed 0 degrees at some point. It didn't just magically jump from being negative 20 degrees, or excuse me, negative 10 degrees to positive 20 degrees. It had to have crossed 0 at some point. And within the context of the intermediate value theorem, there's nothing particularly special about 0, but I think it is kind of helpful to say, okay, if we start off as a negative, end up as a positive, we have to cross 0 at some point. And that's essentially what this says, right? If you start at 2, you end up at 4, you have to cross 3 at some point. So what this theorem does, though, is it guarantees the existence. So it says, okay, there absolutely is some number c for which this is true, but it doesn't tell you how to find C, and it doesn't even tell you how many points you have. You could have more than one value of C that makes this true. So you could absolutely have more than one. It doesn't give you a guide to determine that. It doesn't tell you how to find it. All it does is it says, yep, there's a solution, and that it's up to you to go find it then after that. So if I wanted to use the intermediate value theorem here, it says use the intermediate value theorem to show that the equation has a solution on the given interval, and then use your graphing calculator to find the solution. So here I have square root of x to the fourth plus 25x cubed plus 10 is equal to 5. And I'm just going to tell you right here, just so I don't want to have to worry too much about determining continuity here. I'm going to tell you that this function is continuous on this interval 0 to 1, because if it's not continuous on 0 to 1, then everything falls apart. That means this theorem does not apply. It doesn't guarantee me anything. So what I'm going to do here is I'm going to take both 0 and 1, and I'm going to plug those into this part of my equation. I'm going to plug those in for x, and what I'm hoping will happen is I'll end up with two numbers around 5. I'll end up with one number that's less than 5, one number that's greater than 5, and I'll say, great, that means that our function has to cross 5 at some point. We have to cross or y equals 5 at some point in between 0 and 1. So let's go and show that now. So let me erase so that I've got some more room. So here, let's take 0. I'm going to take 0 and plug that in. So here, square root of 0 to the 4th plus 25 times 0 cubed plus 10. This is equal to the square root of 10. Now, if you have a graphing calculator, sure, you can go and figure that out. I know that 10 is bigger than 9. Square root of 9 is 3. So this is going to be 3 points, blah, 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 something else. I don't really know. Something between 3 and 4. And I'm going to do the same thing for 1. I'm going to plug 1 into my function here. So I have 1 to the 4th plus 25 times 1 cubed plus 10 here. So this is, let's see, square root 1 plus 25 plus 10. Here, let's see, 26, 10 would be 36. This one works out pretty nicely, is 6. So what does that mean? So that means that somewhere between 0 and 1, at 0, we have this point right here of 1, 2, 3, 4, 5, 6. We have this point 3 point something or other, right here, somewhere between 3 and 4. And then by the time we get to 1, we end up at a y value of 6 over here. So we're starting right here, we're ending up here. And what the intermediate value theorem says, it says as long as our function is continuous, if you want to start here and you want to end here, we have to cross this dashed line at some point. And actually somewhere between 0 and 1 down here. So somewhere over this interval, I have to cross that dashed line. Now, it doesn't tell me where it is, but it does tell me that somewhere in between those 2 points, I'm going to cross this line at some point. And we can actually find this, and let me actually get my graphing calculator out here. If I wanted to find the point of intersection between these two, remember there may be more than one, but we're really interested in the one that falls between 0 and 1. So actually, you know what? Let's graph this. I think that would actually be kind of a lot more interesting. So let's see, I have square root of, let me open up Desmos. So here I'm going to use y equals square root of x raised to the 4th power. X raised to the 4th. I already forgot the rest of the function. I'm sorry about that. Plus 25x cubed plus 10. Plus 25x raised to the 3rd power plus 10. So there's my first function, and then here is y equals 5. Here is y equals 5. So I can actually look right here, and I should be able to see, okay, between 0 and 1, if I zoom in really closely, right, hopefully we see, here's 0 to 1, we see right here, and let me see if I can get that point to pop up. Yep, here's 0.834. That is between 0 and 1. So if I were to plug roughly 0.834 and plug that into square root of x to the 4th plus 25x cubed plus 10, that would give me a y value of 5.